Hey folks, our second lesson in electrostatics is about charge interactions, and then talking about the motion of charges within an object or between objects. So everyone's heard the phrase opposites attract, and so for charge that means that any two objects that have a different charge from one another will attract. Now the obvious one is that if you have a positive charge and a negative charge. So kind of one of the rules that came out of charge is that opposite charges will attract one another. And so a proton and an electron attract one another, and objects that have an overall positive charge and another one having a negative charge, they will attract one another. But it is also possible for charged objects to attract neutral objects. So if there's a positively charged object and a neutral object, sorry about the spelling of and there, and positive and neutral, they will attract. And then if there's a negative object near a neutral object, they will also attract. Now, it's a bit misleading because what we'll talk about later is that those neutral objects will have electrons in them that are attracted to the positive, and this neutral object has protons in them that are attracted to this object. So it's not truly three different rules, it's really one rule that just gets kind of bent when there's a neutral object. The the analog for that, or the counterpoint to that, is like charges repel one another. And so if you have a positively charged object and another positively charged object, then you bring them together, they will push apart. And same thing goes if you have a negative and a negative. So they essentially behave like magnets that have the same pole. When you put them together, there's a force between them. So when we talk about opposites attract, there's a literal force that is pulling them together. And like charges repel, there's a literal force that's pushing them away from one another. No interaction comes from two neutral objects. And so that's like if you bring these things near one another, nothing will happen. Okay. Next up is the idea of conductors versus insulators. Now, in some objects, electrons are free to move within the object. So in chemistry, you study different types of bonding, and so the one that you tend to spend the least amount of time on is metallic bonding. It turns out that metals are all conductors because of the way their electrons are arranged in the atoms, and in a solid, the electrons are mostly just free to move anywhere. So if you bring a charged object near a conductor, the electrons can move considerably toward or away from that object. And so all metals are conductors. The human body is a conductor. Water is a conductor. And we'll talk about that later. Insulators. You also, in chemistry, spend more time on ionic and covalent bonding. And so in those types of substances, the electrons are confined to, and here's a word that you haven't heard in a while, the orbitals of one or two atoms. So if there's, if you want to remember the things that you studied in chemistry, electrons exist in a cloud around the atom, and each of those electrons is located in a specific shape or average location called an orbital. And if there's a bond between two atoms, they share an orbital, and the electron kind of zips around within that space for the most part. And so in ionic and covalent bonding, those are the types of bonds that cause electrons to be confined. So ionic substances, covalent, also called molecular substances, and in general, non-metals. And so we'll hopefully give some examples in class of these types of things, but something like wood or glass or air, those are all insulators and basically they don't allow electrons to flow very easily. And so you'll explore this in the lab. The last part of this lesson is about conservation of charge. That's kind of our biggest thing, and you won't apply it too much, but you need to know what it is so that you can understand what's happening. So conservation of charge, this is our third conservation law, says that it's impossible to create or destroy charge. Now, it's not actually impossible. It is difficult to do that unless you have a very large energy source. So we talked about a neutron being made of an electron or proton. You can smash them together and you make a neutron, but the charge didn't get created or destroyed. You just combined two things. To actually destroy an electron or destroy a proton, that takes a lot of energy that we just don't have access to in a high school lab or even potentially on Earth. So it's very hard to do that. And so the consequences of that is that charges simply move around. And so the total number of charges in an object doesn't have to remain the same. That's just because the charges either leave that object or they enter that object. They have to come from somewhere else or they have to go somewhere else. And so this conservation of charge idea is something we're going to run with in the rest of the unit.